Hello, my name's Gabe. For this problem, we're given r is equal to 4 cosine of 3 theta, and we're asked to find the maximum value of the absolute value of r and any zeros of r. So let's go ahead and let's get started by finding the maximum value of the absolute value of r. So let's begin by first thinking about the absolute value of r. So we know that r is equal to 4 times cosine of 3 theta. So the absolute value of r is going to be equal to the absolute value of 4 times cosine of 3 theta. Now this, we know, is going to be equal to the absolute value of 4 times the absolute value of cosine of 3 theta. And again, the absolute value of 4 is 4, so we know that this is equal to 4 times the absolute value of cosine of 3 theta. So just looking at this right here, we know that the largest that cosine of 3 theta is going to get in absolute value is going to be 1. So that happens when cosine of 3 theta is equal to 1 or minus 1. So what that tells us about the maximum value of r is that the maximum r value is going to be 4. And after we write that down, we'll go ahead and we'll find out where that happens. So the maximum value of the absolute value of r is equal to 4. And again, that's because the largest that cosine of 3 theta can be in absolute value is 1. So what we want to do now is we want to solve the equation, the absolute value of cosine of 3 theta is equal to 1. So what we want to remember here is that when we try to solve this, we're really trying to solve two different equations. The first equation is cosine of 3 theta equals negative 1. And the second equation we're trying to solve is cosine of 3 theta equals 1. So trying to solve this first equation, cosine of 3 theta equals negative 1, we know that cosine of 3 theta is going to equal negative 1 when the angle 3 theta is equal to odd multiples of pi. So that is when 3 theta is equal to 2n plus 1 times pi. So solving for theta by dividing both sides of this equation by 3, we have theta is equal to 2n plus 1 divided by 3 times pi. So since our r is symmetric to the polar axis, we only care about values of theta between 0 and pi. So here if we go ahead and substitute n equals 0, well, we'll see the value, the first value which we care about is pi divided by 3. And if we substitute n equals 1, well, we're going to have 3 divided by 3 times pi, which is just pi. And if we choose any value larger than 2, or larger than 1, including 2, we're going to have values which are larger than pi. So we'll keep repeating as we move around. The next thing we want to solve, or the next equation we want to solve, is cosine of 3 theta equals 1. So the solution to this equation is going to happen when our angle 3 theta is equal to even multiples of pi. So that's when 3 theta is equal to 2 times n pi. We can solve for theta by dividing both sides of this equation by 3. So we have theta is 2/3 times n pi. So again, we only care about values between 0 and pi. So what we see is that if we substitute n equals 0, we're going to have theta equals 0. If we substitute n equals 1, Well, we're going to have 2/3 pi, or 2 pi divided by 3. And if we substitute any n value larger than 1, such as 2, we'll have a value larger than pi. So these are where the maximum values of the absolute value of r are going to occur. At pi over 3, pi, 0, and 2 pi divided by 3. Now the next thing we want to do is we want to find any of the zeros of r. So to find the zeros of r, well, we want to solve the equation 0 is equal to 4 times cosine of 3 theta. So here we can divide both sides of this equation by 4, and we end up with the equation 0 equals cosine of 3 theta. So this is the equation that we're looking to solve. So we know that cosine of 3 theta is going to be equal to 0 when 3 theta is an odd multiple of pi over 2. So what this tells us is that if we solve for theta by dividing both sides of the equation by 3, what we'll have is theta equals 2n plus 1 times pi divided by 6. And again, we only care about the values between 0 and pi. So if we substitute 0 in for n, what we're going to have is theta equals pi divided by 6. If we substitute 1 in for n, we're going to have 3 pi divided by 6, or pi over 2. If we substitute 2 in for n, we're going to have 5 pi divided by 6. And if we were to substitute in something like 3, well, we would end up with the 7 pi divided by 6, which is larger than pi. So the zeros on the interval from 0 to pi are pi over 6, pi over 2, and 5 pi divided by 6. Thank you.